You're Canadian there for a second. But it's recommended that you use a replication controller even if you're creating a single pod.
So that's all fine and dandy. We've got the replication controllers. Imagine we're not a local cluster, we have 5 or 10 versions of this running. We want to expose the pod to the internet. So Google Compute Engine, if we use the view-control command, that will integrate with the cloud provider to add a public IP address to the pod. So view-control expose replication controller my Nginx for you, type load balancer, and then a public IP address. In this example, this public IP address is actually the IP address of my Vega box. So from my machine, I actually can go to 4080 of the Vega box, and it's actually the Kubernetes service that I get with that IP. When I run this command, I'm going to see that the service has been created, and it's going to map to an external IP address to the service. When you're running the local cluster, it has a configuration file that you can edit if you want to choose a different IP range. By default, if I didn't send the public IP here, it would get something in the 10.0.0 something range. So if I'm using Weave or Open Contrail or things like that, or any kind of overlay network, I can configure that overlay network to have that IP space so it will just work. But if I have some other networking scheme or some other thing, I could edit that file and change it to the right thing. So even though I pass the public IP here, it's still going to use this public IP that I pass along, as well as the one that it chose for the service itself. So it's important to make sure you edit that to something that's actually routable in your network. So that's all fine and dandy. But now we want to move on to configuration files. So most people eventually want to use declarative configuration files for creating and modifying their application. So to get started with config files, we've got 2 options. We can use YAML or JSON. So in addition to the imperative style commands described before, we can have these configuration files that we store. And a nice thing about this is that we can check these into version control and change the files, and we can have code review around them so we produce a more robust, reliable, and archived system. And I tend to like that approach because you start off simple with your configuration file and start adding things to it. So most of you from a DevOps background are familiar with Puppet and Ansible, Chef, things like that. So you're used to kind of looking at the delta between those files, and it makes a lot of sense. So running a container from a user-defined pod configuration file looks something like this, and I apologize that the font is so small, it's just hard to fit on the screen. So it's really straightforward. We describe what API version we want, and then we want a pod, and the metadata. So here we have the label that this is the Nginx app. We have the name, we have the namespace. So by default, we're just going to use the default namespace. If we have a more exotic setup, we can have individual namespaces. So imagine you had your QA team could have one namespace, production could have another namespace, staging could have another namespace, and you could have one large cluster that supports all those namespaces. Now, in the container stack, we say we want to image Nginx, and this is the name that it's going to pull down from your container registry. So if you're using Quay or you're using Google Container Registry, it'll pull it down. And you can set the pull policy. So in this case, we say not present. So if I don't have it locally, it's going to go ahead and pull it down. We say what ports are going to be there. So port 80, it's going to talk to TCP, and its restart policy is always. So pretty standard, simple configuration. And the nice thing about this is, like I said, we can store that file in Git, or wherever we store things, and see how it changes over time. So you notice the difference between a container and a pod. Since you only ask for the former, Kubernetes will create a wrapper pod for you. So you just ask for a container, you just ask for the container, and it's going to make a wrapper pod, and that container will be scheduled there. So you can't view the Nginx start page on localhost. So to verify that Nginx is running, you can run curl within the Docker container. So all the standard Docker things that you're used to using, like Center, Docker exec, work for you. So if you do a Docker PS, you get a list of the containers that are running, you get the show up of that container ID. You can just do it like a Docker exec-it, that container be a bash, and now you have a bash prompt inside that container to try anything out. There, change things on the fly while So when we run the kubectl get pods, we can see the clusters of pods, and we can delete the pod that we just created with the delete pods Nginx. Kubectl claims to start a container with the pods, and Docker PS don't show it. So this can happen if you're running on a local cluster, you're making some changes. And one of the most common reasons this will happen is actually Docker's fault. The Docker daemon will crash. And if you follow the kind of why Core was made rocket, it's because of that brittleness in Docker, that Docker has already been owned by the Docker daemon, so if anything happens to that daemon, all of your containers will go away. So if you're trying this on a local cluster, you might want to make sure that Docker is running correctly. Another issue that you can see is the pods fail to connect to the services by hosting, and that's because if you're running a local cluster, that script doesn't start a DNS service, but don't worry, you can start one manually. So we'll talk about that a little bit. We'll cover DNS and Kubernetes. So Kubernetes offers a DNS cluster add-on, which most of the supported environments enable by default. So we use SkyDNS as a DNS server with some custom logic to slave it to the Kubernetes API server. And what's nice about that is SkyDNS relies on etcd, and so does Kubernetes. So we know that everything is going to be stored in a safe, easy to retrieve way. And so let's talk about what things get DNS names. The only objects to which we're assigning DNS names are services. So every Kubernetes service is assigned a virtual IP address, which is stable as long as the service exists. As compared to pod IPs, which can change over time due to crashes or scheduling changes. And this maps really well to DNS, which has a long history of clients that, purpose or an accident, don't respect DNS CTLs. So we found with any kind of service discovery around DNS, you always have to be careful about the DNS implementation, because everyone's interpretation of the spec is slightly different. But one Java library thinks it's a TTL, and how you're putting it on there is completely different than some node package that thinks is going to be there. So we just kind of trust that these things are going to stick to the service. And the DNS name format for services, services get a DNS name with a format like my-service.my namespace.service.local. So you want to make sure that you don't use this service in the namespace label, so you can avoid conflicts. But if we think about making several smaller Kubernetes clusters in an environment and looking for things in the future like Ubernetes, which is going to be a federated control plane around many different Kubernetes clusters, you can get pretty creative with the format for these DNS names and get a good sense of like, is this the prod service, is this the testing service, staging, what have you. So I'm glossing over this quickly, but coming from a Mesos background, being a former Mesosphere person, this is exciting for me to have this just built in and not have to roll my own HA proxy / zookeeper Mesos DNS thing to be able to figure out what's running there. And it's not open to interpretation. This is just the way it works. So running a replicated set of containers from a configuration file. So running the replicated containers, we need a replication controller. And the replication controller is responsible for ensuring that a specific number of pods exist in the cluster. So in this example, we have the replication.yaml file, which is the Kubernetes. You can check out, use group control, and create that full file. One thing I didn't touch on here is that it's probably good practice to put these files in a subdirectory. So if you're checking out the default, you're cloning the Git repo, everything is those examples are the kind of good examples of how you would want to namespace the folders. So it makes sense. So in this replication YAML file, it's even smaller font because there's more data to show. But basically, the biggest things that we want to touch on are that we're saying we want 3 replicas of Nginx. Everything else is pretty much the same. If it's not present, we want to pull down that Nginx and the 4080 restart policy of always. One thing to keep in mind when you're setting up or moving to Kubernetes, moving to containers, a gotcha that a lot of people end up with, is that they naively start making giant Docker containers that are basically clones of VMs that they were running in the past. So these containers can be, and we've seen some in the 1.5 gig range or larger. And people are like, I don't understand why these things take so long to start, or what's going on? And they've got a 40 node cluster. And you try to explain to them, like, S-flow or NetFlow or any kind of monitoring of that network, it's like, well, you just asked 40 boxes to grab 1.5 gigs of the standards because you made an update, and then you made another update, and half of them haven't even grabbed it yet. So even though you have amazing networking, you're still causing yourself a lot of pain to pull these down. So I think it's really important for people when they think of containerization, think of it differently than just building this VM replacement and really carve up those services the right way. A good example of that, I keep touching on the Nginx example, but there's no reason for my data to actually live inside that container for Nginx. I can use a container volume, or I can use a volume mount into that container that actually has the source of my app. I'm really just worried about the container for isolating that service and running Nginx in that container. So to delete the replication controller and the pods it created, we just use delete RC as the shorthand for replication controller, Nginx, and I'll go ahead and clean that all up and delete it. And if this was something where I never wanted to have this container again, I'd go back, look at the file, and I say, I've got the container image from Nginx. I could go and purge that image off of all of my systems and remove it to save space. And that's another thing to keep in mind when you start to use this, is that you're going to clutter up the system, quite a bit when you're in development mode and you're trying a lot of changes and you've got a small file system built as containers. So it's a good idea to kind of audit your disk usage on the individual nodes and get a good sense of what's actually cluttering that file system. And to that end, if you end up changing, like someone in your group decides to, well, our Nginx container should also have this New Relic agent and have all this other stuff in it, and well, might as well have the MySQL client because I want to, for some reason, essentially that container run the MySQL client because that seems to make sense to me. And then you come in and you're like, well, that's not smart, and you want to squash that container down. It's important just to make sure you delete all the old copies, and so you don't end up with like a newer, smaller version and then older versions that are huge and it doesn't make any sense. You're like, I cleaned up all this space, but I still have all this disk space used. So, things to keep in mind is that Kubernetes is pre-production beta, but V1 is coming soon. So the V1 launch will be around Reilly's OSCON event, or conference. So we're doing an event on the 21st. Everyone's welcome to come if you're happy to be at OSCON. There'll be a lot of really interesting demos and cool things to cover. So, kind of my safe harbor statement is, all the concepts and architecture in Kubernetes represent years of experience designing and building large-scale cluster management at Google. The Kubernetes project itself is still under heavy development. So you can expect bugs, design and API changes as it's brought to a stable, production-ready environment. So as we're closing in on V1, we actually did a code freeze last Friday. And it's more like a code slush. So all the PRs that are currently open are waiting for you to review. Any new PRs have to be for bug fixes or anything that we're trying to close out for the V1 release. So we're really looking at a very stable V1. And the biggest area that you'll see stability is in the API spec itself. So right now we're making sure everything works on the Beta 3 V1 API. And then once that's solid, and that is the V1 API, that's going to be locked down. So at that point, you can really trust, as you start to tool around this or build things that interact with the API directly, that things are going to stay solid for a while. And, community discussion support. If you have any questions or if you want to start contributing, you just reach out. We don't bite. Everything's on GitHub. Everything's raised through issues and pull requests. The Kubernetes team is mostly hanging out in IRC on the Google Containers channel on Freedom. One thing that's really interesting here is that there's always going to be 24 hours a day a member of the Google Cloud Platform team that has on-call rotation and sitting can't be in that channel. So you're guaranteed to get someone that's a committer on the project any time of day that's there for a sole purpose to answer your questions. And no questions are not worth asking. And the channel on IRC is also archived, so you can go back and look at all the past conversation and figure out how to do things. So while we were developing things, it actually was really powerful. As the API changed, as certain concepts changed ever so slightly, it was a great way to get form around like, okay, well, let's call this now, or let's call this. We've changed things that we used to call the nodes minions, now the nodes, like half the things that's in minions, and just kind of keeping up with the state of the project. It's a great kind of central source of truth in IRC. We also have the Google Containers Google Groups mailing list for questions and discussions, as well as the Kubernetes announcement list for important announcements. And that's a really low traffic, no chatter list, so if you join, you're not going to get spammed by a bunch of stuff. And a shameless plug, since I'm the CEO of Kismatic, the enterprise support company for Kubernetes, I say, if you're a company looking for more formal engagement around Kubernetes and containers and so forth, contact Kismatic on Twitter, or reach out to the Google Cloud Platform team and talk directly to Google if you have needs around Google Container Engine, things like that. So that's all I have for the slides. I'll jump into the terminal and kind of show you some stuff. So before I do that, I'll ask, does anyone have any questions?
You talked a little bit about case volumes. How does Kubernetes do volume management? The API calls to provision a volume, to dismount it, detach it, reattach it.
Yeah. So when you set up the spec for the pod, you have everything available to you that you would have normally in Docker or containers. So you do a container volume, a volume mount, things like that. You declare that in a definition. So as long as that pod is up, that storage, is going to be there for it. So we see, some customers that are wanting to do things where they have decent equipment behind it, things like volume storage, stuff like that. They can do a volume mount into a container and actually have that backed on the host node itself, to that volume storage directly attached to HPA or something, for example. But we are working on better storage primitives, so you'll be able to have stateful services like databases run, and know that that container volume is going to be there, and exist. At the Kubernetes gathering that we did back in February at CloudOps, we spent a full 3 days just talking about what that's going to look like, and everyone from the different organizations that were present had a little different opinion of what things were looking like, but probably will shape up around V1.1, V1.2 of Kubernetes, that you'll be able to have things like managed IOPS, for example. So I need to have this kind of storage that can write at this rate, or I just need to care that this will eventually be written like conform storage in a Facebook use case. So we should, as we get past V1, have more compelling things around storage besides just the primitives that Docker supports. And there are things like the cluster HQ guys have a really nice plugin that uses the CFS backend, and there's other startups around container farms.
How is resource data?
Yeah, so right now, things are pretty generic. The current scheduler is nothing more than round robin, really. In V1.1, the first scheduler improvement that we're going to have is the least used. So we built, at Kismatic, we built a tool on Google called Cluster Insight. And what that tool does is try to reconcile state between the Docker containers themselves and the base node that things are running on. So the work that went into that tool is going to be put into CAdvisor. So CAdvisor will be able to store that with Cubester and store that in Grafana and InfluxDB, and be able to decide what are the most least used nodes. So the next scheduler you can see the least used node scheduler, so that they should have a better distribution of things throughout your cluster. And at Kismatic, we're working on another scheduler based on Maltese work. So it's a flow-based scheduler. So it's basically the first open source implementation of Omega. So if you want more exotic schedulers, you'll have that available to you. And as part of the work to get the least used scheduler, which, like I said, we're going to land around V1.1, V1.2, we're abstracting away the scheduling logic so it'll be easier to plug custom schedulers in. So people like the R&D lab with VMware are working on building their own schedulers that will work everywhere on top of like the ESX environment, things like that. We're also looking at things we can do on top of OpenStack with Ubernetes to have better schedulers and things. So it'll just get better once we get past V1. But right now it's sophomore investment. But they're really looking at key focus to build the most amazing schedulers and get all the basic components in first. Anyone else?
You see the first one regarding the system.
Yeah. So before Docker Swarm was called Docker Swarm, it was Citadel, and it was shown off at the DockerCon EU conference. And so I would formally Mesosphere, most of my team is all formally Mesosphere people. We work with Docker to review that and look at it from a Mesos perspective. And really the key concept there was that it's for 100 nodes or less, it's more or less using the Docker API and being able to use Swarm. And I look at it like it's a great test bed. Like if I'm a shop that's trying to move from my traditional architecture to like a microservices architecture, Docker Swarm is perfect for that. Like I can try it out, I can share my containers with my coworkers, I can say, are you sure things are going to work? And we look at, Kubernetes that we're trying to get. Now you need to do that in production. You've proven that your containers will work. So if you look at, Docker Swarm right now, the API supports Mesos for backend, and we're working to make Kubernetes one of the supported backends as well. So you can use, your developers can still use the Swarm API, but then run things back on also.
I'm still unclear on the overlap and non-overlap between Mesos and Kubernetes. It seems that there's a ton of things going on.
There are. And there's a ton of things that are great. So, the biggest difference, I would say, is like something you touched on. The scheduler is much more robust. That's in Mesos today. So if you're really looking for scheduling, if you're looking for, fair resource utilization and being able to build frameworks and do all that, like Mesos is the way to go. And Mesos gives you 4.5 years of operational experience at Twitter, things like that, where Kubernetes is a greenfield effort and is still pre-production beta. But not to say things incorrectly, I kind of feel like if I'm looking at Mesos and look at Ben Hinman, the co-creator of that project, he did that while a PhD candidate. He got excited by reading the Omega white paper and got excited by doing an internship at Google. So the way I kind of look at it is like, we've got Mesos that got this 4.5 years of accelerated operational experience built off of excitement around a white paper while a PhD candidate. And then you got the people that wrote the white paper and wrote the system behind the white paper, deciding to do a greenfield effort and call it Kubernetes. Which one are you going to trust? And it's kind of like my decision: do I buy a real Lamborghini or the one that looks like a Lamborghini from China? So I love it, but I'm biased.
Come on, Patrick.
I'm going to probably pay for that statement.
It's like, we recorded that.
Go ahead, Frank.
I have two questions. One, I guess these two tools like
And this is the first one.
console. Two questions.
Okay.
First, here you like here in graphs and notice about tools like console. It seems like there's a lot of similarities, but my second question that I have is there support for S-driven
Yeah, so to the first question, there's a lot of similarities, right? There's only one way here. There's kind of a way to do this, a way to orchestrate containers, a way to think about it. And so all the concepts are relatively similar. So I tend to like the ecosystem around Kubernetes, just the excitement when I look at the number of stars on the project, the number of forks, the number of contributors, the low entry, like not to say anything negative about Mesos, but Mesos, I want to write something beyond the framework. I want to change the core functionality of Mesos itself. I need rockstar C++ developers to even wrap their head around how to do it. With Kubernetes, everything's going to go. It's pretty easy for me to take the intern and wrap their head around it and get them contributing. So with the API becoming solid and you want to see what tools out there they could take advantage of Kubernetes by using the API, do things directly. If that's for some reason too heavy for you, feel free to use any other tools. I kind of look at the more tooling out there, the more we try to simplify things for developers, the better everything is going to get. So, that's why I'm excited about Docker Swarm. I'm excited about having that easy API, getting people to use Docker, thinking about containerization, thinking about how to build microservices, and how to migrate their existing apps over to containers. And then for your second question, everything is fairly pluggable. So I'm not 100% sure, but if there isn't a plugin already available, there's something that someone's working on. So I would have to get back to you for do some research. So second one.
I have a question about more real-life deploys. If I have a YAML file and I say deploy Nginx in pod in 3 instances,
So as you update so in these examples, I had this really simple, I need Nginx. So you can use all the nomenclature that you would use in Docker directly. So I could say latest, or I could say pin it down to a specific version. And we now have support for rolling updates. So as you do that update, so the concrete use case that I do, and we do POCs for customers, the concrete use case I use there is like, let's say I have Redis running inside a container, and there's a flaw with the Redis hashing function, so I need to update that Redis container. I can do that, push that to my container registry, change my spec to use that newer version, and install it through a rolling update. So I'm not just, my cluster not all at once is updating Redis, it's doing it per pod update. And another distinction to keep in mind with the pods is that, if I have a Redis container running in the pod, it's not going to co-locate more than one of those, typically on the same host. So I have some isolation, services. And as we mature past V1, that'll actually get even better. So we can have some policy-driven decisions. So you can say things like the concrete use case of MySQL. I don't run MySQL slaves in containers, and I don't want all 10 of my MySQL slaves to run on that same node, because that node wants to run slaves. So there's more flexibility.
I think it said poll only if it doesn't exist on the box. I probably should change that to be like poll alert.
No, because if you actually put it to latest, once it notices that there's a new container that is a newer tag than the one that is running, it will go ahead and pull it because it doesn't exist locally. So that's only in the container registry.
But with that rolling deploy, is that something that's going to come with the later schedulers to be able to find soon? It's like sometimes a rolling deploy is not, it's too not enough. Maybe I want to do like the AD thing or something.
Yeah, I want to ratchet up 1% at a time, something like that. So
maybe not healthy, so I need to make sure that they're healthy before I roll.
yeah, so you can add additional functionality in the future. And those are things that we're looking to make applicable. So right now, I would say it's similar state of the scheduler. It's in a memory form, but it will be more robust as time goes on. Hold on, you guys have two questions. Let's look at it.
Thanks. I was interested that looking at the outside of IDNS and services, the new thing, that's kind of cool because actually the piece of the market that's the interrupt microservice or whatever behind there, it makes sense from security or whatever point of view. I was thinking, well, what is the multi-tenancy security access level? Is it something you're built in or something you've got? How does that actually work?
So, what our focus is to add all kind of last mile enterprise features to Kubernetes. So, role-based security, Kerberos, LDAP, Active Directory integration, and that's definitely one of the things that excites me about the Kubernetes code base is that it is so extensible and pluggable and hookable, and it was built like that from day one. So, if I look at the Mesos use case, and sorry to keep comparing and contrasting, but it's the only other model that I could use. When trying to add some plugins support things beyond frameworks and Mesos is actually difficult. So we had to rewrite a lot of code to support those features. Even like dynamic slave attributes were a difficult thing. It required changing C++ code in a non-trivial way to do it. Where in Kubernetes, it's a Go code base, so it's built that way by default. The plugins are there. So we're looking for our plugins to kind of provide process guidance on how to do these things. But there's no reason you can't write your own plugins, in Go or in another language and use it in binding, if you want to provide whatever extra level of security you want.
I was talking to earlier, some of the things like Go, because you have simple class of Python, whatever, or even security, they can in a container piece, have that exposed, and then that too. You can build that, which is good.
Yeah. So yeah, just having that flexibility around that. Good.
There's support for launching things besides Docker.
So right now it's Docker and Rocket. So things that we're looking at doing, at Kismatic or Kubernetes are supporting VMs inside containers, much like GCE runs, because we have some clients that want to be able to support Windows, and with Windows embracing Docker so much these days, and working on their own Docker integrations, we think that would be really exciting. But it's very early prototype stages at this point. But ideally, that'll be there in a not too distant future, because there are a lot of people that are asking for it. So right now, you kind of have to rely on having another standby node. Similar to my mind and how I had you do MySQL back in the day, where I had like a standby master ready to go. But keep in mind that everything's backed by etcd, so as long as I can make sure that etcd is resilient and that I have an authoritative copy of that somewhere else, I have relatively low risk of losing things because that state information is stored there. As we get past, I keep saying this, but as we get past V1, that'll be more robust. And that's definitely a case for, like today, our picking something Mesos, beats Kubernetes because they have that fallout. I have a multi-master scenario, I have fault recovery, things like that. But I would say that you won't get past probably version 1.2 without having a very robust strategy.
So the master with services are still accessible to the
They're not something, yeah. But you could, with the code as it is today, we can talk about this offline, you could actually have a pretty resilient setup that you could do that could recover and wouldn't be all mixed up.
Can you talk to any person experience with manual versus read versus on the overlay networks versus just using Kubernetes native network in smaller days, especially around person experience, troubleshooting.
Yeah, so Google Cloud Platform, they have pretty amazing networking capabilities. You're able to do IP per pod and trust that that's going to work with a Google Container Engine. Trying to replicate that same setup, in your own environment is sometimes fairly difficult because your networking folks aren't willing to make the changes or aren't able to make the changes because of some reasons that they don't necessarily share with you. So the overlay networks become very interesting, to use. So the bit of operational experience I can give you there is that the overlay networks work really well in small testing environments, but a lot of them rely on user-linked code to be running, so the overhead becomes very expensive at any kind of scale, or the latency becomes too high if they're doing bridging between totally different networks across different availability zones. Of all the solutions that are out there right now, I'm really excited about the work that the Reworks guys are doing. Actually, don't know if I can share what it is, but they have something coming out in June that will be really exciting.
Pretty good. Like 2 or 3 weeks ago, on that performance study, I think we was roughly 10% from small versus final, which was not great. But that's a side. But for things like multitask or any kind of one-on-one communication, I'm assuming Kubernetes is not there right now. We have to rely on some other form of overlay network.
Yeah. So, one thing I just wanted to showcase is so by default right now, when we take out, with long repo, we bring in a local cluster, you end up with a web UI that's built in to the API server. So if you go to /static/out, it'll redirect you to the dashboard. So in this case, we only have one node running, and it's the local host. But we have a nice graphic there that kind of gives us the state. So we're able to see the CPU, memory, and file on that node, and that's being updated in real time. It's kind of hard to tell on this version, but you can see that I peaked out here, so I have a good sense that in this most recent time interval, I've never gone past that utilization from a CPU. But as you have a decent sized cluster, these bar gauge components will render across the screen, and they tile pretty nicely. And then once you get too many nodes, the legend moves off and becomes a clickable artifact. So right now, the web UI focuses on parity of all the CLI commands that are available. So in this case, I want to see my pods. So you can see I have my Nginx pod running. That's its IP. It's running. That's the container. That's the image. That's the host. I have no labels applied to it. I can go through. These are the examples that I had in the talk. So I go through and see my nodes. I just have the one node because it's a local cluster. I can see my replication controllers. I've got my Nginx replication controller, and I just have one replica, and I can see the services. So here I have the my Nginx service, and it's exposed on this IP. And the reason I switched over to this is this is my 10.0.0 IP address, so I would have to accomplish this through using the overlay network or Contrail integration or something. And if you notice in the example that I gave, I actually also passed the IP address of my vagrant box, so I could get to the service that way. So this is So because I set that service up earlier and saying that it should use that public IP on port 80, I can just go to the IP address of my data box itself, and it's actually that service in Kubernetes. And when I think about the DNS integration, that's really powerful. Right now, because I only have a single node, I can only have a replication kind of one. But if I had, even a small 10-node cluster, that becomes pretty powerful to know that it's always going to act as a load balancer by default and make sure that we get to that service. And jumping back to where you want to just go through the other views, I can see events. So right now, because I'm running a local cluster, I don't have a buffer for the events, and my events are empty. But a concrete use case that we go through around POCs, back to that Redis example, is if I see that I'm having a lot of events and Kubernetes has decided to just constantly kill that pod and kill that container because of errors, I have a chance to click in, I'll use one of the other views as completed. So I would have the ability to jump in here and say, okay, that container that's running in version 17 has a problem, click on it, check it out in the container registry, make the change to the hashing function, update that image, push it to the container registry, do my rolling update, and right here in the W I see that now I am running that new version of this node. Go back to my events and see that I'm no longer getting that solve that problem. And you're able to do that all without SSH, that box or having to do anything from the terminal. So right now it's all of the read commands that we support in WI, but we're looking to add editable features as well. Those won't probably land until after V1, but all the YAML JSON configuration files will have editors and nice forms that you can use that have all of the defaults. So you know that you can file out of it.
So I like the idea of exposing this UI to developers, but say I want most people to use the checkbook. Would there be a way to expose change?
Yeah. So there's a configuration around this, and so in your environment, you can just change that configuration and disallow. So our role-based authentication plugin, you'd actually be able to very granular with it. Without the plugin, you could just change the configuration file and say only this particular user has this right, even though other users have this right. And you can also use normal active table firewall rules to disallow people from going to certain endpoints and doing other things too. So, but we're trying out of the box to have a new policy and very and another thing to keep in mind with the dashboard, so it's all Angular material and Angular JS project, and the code all gets compiled down, put into a Go binary, and shoved inside the API server. So it lives inside the API server. It's not anywhere else. But the tabs across the top, so where it says dashboard at the top, that's the dashboard tab. We have a simple format for making new components, and so when you make a component, you make a manifest file, you make a directory inside of components. And once you have that there, it'll just be a new tab. And the interesting thing about the API server is it acts like a proxy to all the services that are running. So because this is an Angular app that uses Ajax, I can actually just bring up a pod with my component that I want to add to the web UI and create a manifest file. And it can then route through the API server to that container and run my other things. So concrete examples of that would be intrusion detection system. If you wanted to run a node in a promiscuous mode on an overlay network to be able to capture more network data or other things, or storage. You wanted to see how, if you were using wireless storage, for example, or something like that, you wanted to see what the health is beyond just what you see here. You could add your own components. So we tried to make it, building the components be as simple as humanly possible.
Could you describe it then as it goes through that property? It sounds like a checkpoint, like a bottleneck.
So everything's exposed, that way right now through the API server that has kind of a central point. And I think of it more like a bastion host than as a choke point. So you could still add, if you were worried about, throughput, or you had like a high service availability issue, you could still have other containers that act as that entry point with other things. It's just one way that you can do it. And it's a sense of novel approach that with this particular web UI, where I'm able to run everything from the API server and still allow you to get to any other services that are possible.
Not that I don't disagree with the decision, but can you talk a little bit about the design decision to have Kubernetes not span multiple availability zones?
So, as I stated before, like the team is the same people worked on Warrior Maven, so they're very influenced by the decisions that were made in Warrior Maven. So the idea of having a federated control plane, and what we're working on with Kubernetes, being sitting at the top, maybe smaller Kubernetes clusters, always seemed like the logical approach and simulates basically how war works. So that was kind of why that decision was made. As the project matures, things might change. Other community members might take it in a different direction, but that's kind of where we're at right now.
Talk a little bit more to the Kubernetes integration, Kubernetes and like where it's are.
So right now, the only thing that we have on Kubernetes is the RFC, which is pretty easy to find if you search Google Kubernetes. And you can see the scenarios that are drawn out there and participate in the RFC. So if you wanted to add similar scenarios or use cases, we can make sure that things will cover that. But an example of how we see it running now is that I can have a Kubernetes cluster on premise, I can have one in DigitalOcean, one in AWS, and I want to have one central source that I can trust to have policy-driven decisions. So if I have something that doesn't need anything from origin, doesn't need anything from on-premise, it's just like an entry size or it just needs access to an S3 bucket. Kubernetes is smart enough to say, okay, these containers fit this, this criteria. I can go ahead and run them here. They can be scheduled here. They don't ever have to waste resources on premise or other total cost of ownership calculations that you come in like saying, well, right now DigitalOcean is way cheaper than AWS for this type of workload, and we'll run fine there, so let's go ahead and schedule that there. So there also can be a cost saving component as well.
I have a question on the load balancing. Is it purely DNS load balancing that it uses, or is there loads and it's proxy? And how would SSL measure when you're trying to have service like architecture services?
Can you repeat the question for the camera?
So to repeat the question, it was when we have services, how can we have things like SSL on them, and how are they exposed to their DNS, and how's the load balancer implemented? Is it just implemented in DNS? Right now, the load balancer is that actually the master is making the decision that it's going to basically use IP trickery to pick the right pod that's going to service that request. And it's a fairly unique approach right now. It's not just a DNS round-robin type set, but it's actually talking to the master and it's making sure to attach the right namespace. Another thing to keep in mind with Kubernetes is exciting to me is that the network namespace is actually attached at the node level with that pod, not to the containers themselves. So I can co-locate many containers inside one pod and they all share that same network stack. So you have a lot of interesting use cases that you can do there. And as far as SSL, in the cluster by default, since version 14, I believe, I could be wrong, we have SSL by default. So you can have a real SSL cert at the master level. So we typically see there, because we have the DNS nomenclature pretty well spelled out, you can do a wildcard cert or a multi-level wildcard cert to cover every kind of permutation of service that you could make. So you can make sure that you have end-to-end SSL to the service. And then inside the cluster, we also are working on TLS support for any inter-cluster communication. So you can make sure that you have end-to-end security both inside the cluster and outside of the cluster. And typically for people that are trying to offer, services through SSL, they can put an SSL certificate at the zip level and, off the cluster altogether and not have wasted the computational resources of the cluster just for SSL, external SSL traffic. So pretty much all the flexibility you have in the system as well, if not a little bit more. How are we doing this time?
You tired?
You keep going. So here's another day comes and hey, we left your meetings back. So right now I can't speak too much to that because I don't
Can
have
you repeat the question again?
restate it over time so much better.
Yeah, it's Kubernetes is going to dive into eventually or now intra container monitoring, sort of like processes like a monitoring solution or system features, but the authorization.
So restate the question in compressed form. Will Kubernetes do anything about monitoring inter-container communication, like process trees, things like that? So if you look at the RDH component that we have right here, it's actually getting that data from CAdvisor. So CAdvisor is looking at the individual containers themselves on that node and able to give metrics around each one of those containers, and it stores them in Influx DB, which is time series database. So using the Grafana and Euster backends that Google created, you can actually go back and set your time and see, what the health was of a particular container. So I can start to get at things like anomaly detection. So see that this exact same Nginx container ran different on this node than it ran on this node, and there wasn't any noisy neighbors or there wasn't any other contention. Right now, like every day, CAdvisor is trying to get better, and now that's been built in by default. You can see more and more land there. But there's no reason you can't use any of your own monitoring, homegrown, New Relic, and anything that you have to also augment the stats. The only caveat I would give is like any system or instrument, the more you slow the thing down. Otherwise, I would just put features that I have. Any other questions? Actually, sorry.
One back here.
Maybe naive question, but if I want to control the update policies on the resource allocation policies, really, how do I go about it? Do I need to write my own schedule? What should I do?
So right now you have to augment that functionality yourself. As we move past V1, and more like the V1.2 area, we should have better policy-driven decisions there. One of the plugins I mentioned before, or Kismatic, is the role-based access and be able to have policies there. So, concrete use case for that is being able to say like new hire developers are able to get to a replication count of 3, never downgrade a service or never upgrade a service, so whatever criteria is there, and to have it be as flexible, and as expressive as possible, so that you can really fine-grain control or looser policies. We will publish an RC around that shortly, probably right around the V1 launch time. So look for that, and you can help give some scenarios to make sure that we create that way. No more questions? Okay. We're mainly in that. Thanks, guys. I appreciate it.
Thanks, Patrick. We appreciate having you today. And feel free to hang out, ask these guys questions. I know Joseph's here as well. He's somebody who also deals with Kismatic as well. And our next meetup is June 18th. We're going to have Stackstorm, LinkedIn. So if you're interested in workflows as a service, show up. Thank you.